Welcome to my video. In this video, we will discuss and show how to perform etching process. Well, the first question is, what is etching process? Etching process is a kind of technique that is very similar to PCB technology. Sometimes we confuse with these two terms. One is PCB process or PCB technology. Another is etching process. Actually, they're very close to each other, but different. How? Because for PCB technology or PCB technique, we actually interconnect the components of a circuit. But in etching process, we actually emphasize on the microstrip design. For example, in a microstrip patch antenna or microstrip resonator or microstrip filter. In this case, we need a very precise and a very accurate microstrip design over a substrate. So basically, this is the first difference between etching process and PCB process. Secondly, if we go to the effect of the substrate between these two, for microstrip design in etching process, it has a very huge impact. But for PCB technology, we actually focus how to connect the components of a circuit via the conductive line. So here, the effect of substrate is a minor thing. But for this case, for etching process, we focus on the effect of substrate also. So the selection of substrate and the design is a combination of this etching process. So in this video, we'll show how to perform the etching process step by step. I mean, from the design to the fabrication, and finally how to connect the ports and how to finish the whole process. That is called etching process. What is etching process? First question is, what are the steps of etching process? Actually, we have 3 steps, like this. The first step is the export and import. For export and import, we're actually talking about the design, how to export the design that we have already designed in our simulation software, and how to import it to any kind of conversion software for just like, for example, Photoshop or Illustrator, like this, so that we can make it printable. So this is the first step, export and import. The second step is the print and paste. As we already mentioned, we have imported our design to the Photoshop or Illustrator like this, and we already made it printable. Now we will print this design with accurate dimension, and we will paste it over the substrate that we have designed in the simulation software. So the second step is print and paste. And the final step that is very important, and that's the basic thing of the etching process, is the chemical reaction, with the chemical reaction of some materials and substances that we talk about later on and show you. This is actually divided into 2 parts. Number 1 is the process and the post-process, which means we will perform a kind of chemical reaction of our design with some other substances, and after that we need to do some post-processing to finish the whole thing. So the final step includes processing and post-processing. So that's how we will do the whole thing, etching process. So just let's go and start. Before starting the step 1 of the etching process, points to be noted. Each dimension of the microstrip lines should be above 0.3 mm to avoid fabrication errors. Due to the excessive chemical reaction while etching process, any dimension, including interspacing of the microstrip lines, can be damaged, that is below 0.3 mm. So it is recommended to keep your all dimensions above 0.3 mm. Any deviation below 0.1 mm from the original dimension will be considered as a fabrication tolerance. Reference has been given in the video description. We are starting our step 1, the export and import. We have designed a bandpass filter, a couple line simple couple line bandpass filter using some radial stubs by using a material of dielectric material that is called Tectonic TLX. You can see here, which has a height of 0.5 mm
And the other properties of this substrate is the dielectric permittivity is 2.55 and the tangent loss is 0.0019 is the 10D, and the copper thickness of the top plane or the ground plane are same, is 0.035 millimeters. So this is our substrate material, and we have designed a bandpass filter like this. This is the port 1 and this is the port 2, and we considered all the dimensions are in millimeter unit. And let's look at the 3D view of the expected layout that will look like after fabrication. This is the copper microstrip copper lines, microstrip lines, and the blue surface are the dielectric material. And if we look at the ground plane, there will be a ground plane also that will cover the whole copper plated area. So this is our bandpass filter we have designed. Now we're going to export this. So we click on the left side. We are using ADS software. So in your case, maybe it's different, just like CST or other software. But the export is same. I think like clicking the file and then you click on the export section. There will be a pop-out something like this. And you choose there will be a lot of options, or just like IFF, Gerber file, like the Gerber file, EGS. So you will choose the DXF all the time. So you click on the DXF and you choose the destination file, destination of the file. You click browse here and go to your expected destination. So we in this case we just, for example, give a name of the file name of 1. So filter 1. So we click OK, and there will be a pop-up. So we click OK again. So now it's complete. Our export is complete. So we will import this to the Adobe Illustrator. So we'll open the file with Adobe Illustrator. One thing you have to remember, we have designed our bandpass filter is in the unit of millimeter. So while we are importing our design, the layout design in the Adobe Illustrator, when the pop-out will come up like this, the dimension unit, you see the scale is 1, scale is equals to 1 unit, means millimeter. So there are a lot of options like this. If you do your design with some other units like inches, points, like that, so you have to match this, otherwise your dimension will get some trouble. So in our case, it's one scale is 1 millimeter, so we click millimeter, and now click OK. Alright, so you see the filter comes like that, but it's still not printable. We have to make it printable, and you see there's some burst or stroke outside lines of this filter. So we we select the whole area first. We have to make the stroke vanished. We don't need any stroke, so we make the stroke 0. So things will be like this. Now we have to fill up all the filtering section with black color so that we can make it printable. So we choose this live paint bucket and we choose a black color, very dark. Okay, so we click one by one the filtering sections. And filling all the sections to make it printable. Alright, so in our case this is done. It's already been made printable. But one thing you have to remember again, that you see the dimension of this whole structure is, this is the width of this is 38.7 and the height is this height is 10.89. It has to be almost similar to your main design, like this. Otherwise you will get some trouble because it's a micro design, right? So it's a problem if your dimension does not match. So somehow you have to manage this. If your dimensions are not okay, you have to scale your Adobe Illustrator. In our case, this is let's check. In our case, yes, it's almost similar. 38.6 we can see here, and in the Illustrator we can see it's 38.7, so it's similar. and in terms of the feed line, I think it's not that problem. So you have to manage it, and then finally you have to save this file. You have to save this file as an AI format, so Illustrator file. So you save it, AI file, and then click OK, and it's alright. So we have finished the first part, export and import. So let's go with the printing. Next step, the print and paste.
So let's start the work. For printing, we will use A4 format paper, but this is not like the regular printing paper. It has a bit difference with the regular printing paper. The two surfaces, these are not same, they are not identical in terms of the roughness. One surface that is like the regular printing paper, a bit rough. Another one is a bit smooth and slippery. Also, it's kind of glossy. So we will use this surface to print our design and paste it over our substrate. And for printing, we'll use high-quality printer. There are mostly optical printer or laser printer that can give the highest quality of your design to be printed over this paper first, and then back to the substrate, paste it. There you go. This is the design, printed design over the glossy surface of the printed paper. And now we will cut this portion to paste it over our substrate. That's why we have to cut our substrate also matching with this dimension.
Okay, this is the dimension that we approximately choose for pasting this design over our substrate. So having said about the property of our substrate in the design process, I mean, while we're discussing about the export and import step, we already mentioned about Taconic TLX8 substrate, and this is the sample of the Taconic TLX8 substrate. You can see this is the surface of the copper plated area. Also, this is something like identical surface. So both sides are identical. We can use any of this side as either the top plane or the ground plane. So now our step is to cut this surface. Cut this substrate in terms of this dimension, so that we can attach this like this, attach and cut a specific area to match this dimension. Also, for this purpose, to paste this design over the surface of the substrate, we will use few STUBS like this. The first one is a kind of heat shrink tape or kind of heat protecting tape. This will protect the heat that we will apply to paste our design on the substrate. So it will protect the design to be melt or to damage any kind of damage, and also to protect our ground plane, because if we paste, suppose for example if we paste this design over this surface, so on the other side, on the opposite side, we have to protect our ground plane from chemical reaction, so that the ground plane's copper is still like this. There is no harm or there is no kind of defects. So we have to protect our ground plane also. And to protect our ground plane, we will use a kind of regular duct tape. This is a kind of Scotch tape or duct tape. So we will attach this on the other side, the ground plane, and on the top plane we will use this design to paste it by using this heat protecting tape. So that's there we go. You can see we have attached our design on the substrate by using this heat protecting tape, but we haven't attached the duct tape on the ground plane because our pasting step is not complete yet. We will apply heat and pressure all together on this surface by using the kind of machine we're going to show you now. To apply heat and pressure all together over our substrate, we are using this machine. It's kind of mechanical thing. Its name is Instagraphic System. It's a kind of heat pressing machine. So we will place our substrate right here, and then we will apply heat and pressure all together by using this handle. This is the handle. We will apply, we pull it very hard, and we apply the heat and the pressure all together, and we are waiting for the temperature until it goes around 180 degree. Then we will apply the pressure and heat by using this handle. So the temperature is now 186 or 87 degrees centigrade, so it's ready. We will do very shortly our. So here we go. This is our design, the substrate. Now we will place this one like so that the top surface is our design and the bottom surface is the ground plane. So we will keep it right here. Let me just turn this around, and we place on the bottom plate and the upper plate that is very hot, that will give the pressure and heat at the same time. So we have to use this smoothing cover, and it has two surfaces also. This is a bit rough and this is very smooth, so we will keep the smooth side over our design. And now we will apply our pressure and heat all together. It's very hard, you know. So now wait for 1 minute. During this 1 minute, let's discuss something about what other thing that we can do as an alternative of this machine. Well, we normally use iron to keep our clothes, you know, do these things with iron. So with iron, regular electric iron, we can do the same thing, but the problem is it will take a long time to accumulate the heat and pressure all together, because you cannot apply that kind of pressure with this iron. So you have to do this for a long time, like 20 minutes, 30 minutes with this iron. Other than that, the purpose is quite similar, but I'm not sure about with the iron you can achieve the same kind of perfectness or same kind of accuracy to paste your design on the substrate. So now we are very close to finish our heat pressing. Now it will give an alarm. Yes. So we will release this handle and release this plate. Now we have to wait for a while because it's very hot, and the substrate along with the copper layers, these are very hot. You cannot touch with the naked hand, that will burn your fingers. So let's just wait for a while, and after we have this thing cool, then we will move to the next step. That is very important, etching process, chemical reaction. Alright, we're done with the pasting process. We have printed and pasted like this. As you can see, the black portion, this is our design. We have pasted it, and we removed the printed paper and the heat protecting tape, and uncovered this and covered the other surface, the ground plane, protected the ground plane with the regular duct tape by using this. One point is very important while you are while you're protecting the ground plane with this duct tape, make sure there is no bubble, especially on the outer area of this surface, just like the edges. You have no bubble, because that can damage your ground plane by inserting the chemical materials on the ground plane. So now we will make a solution. That's the basic thing, or that's the main part of etching process. We will make a solution, and we will keep this inside the solution for hours until we have this copper areas, all of these copper areas are removed all the way, apart from only this black areas. So only this black portion will be like this, and all the uncovered copper will be removed, and we want our substrate to be open, completely open up, apart from these black areas. So that's the thing, that's the basic concept of etching process. So to make the solution, we need few things, few steps. The first thing, a container. It is recommended to use a kind of container like this, plastic container, so that the chemical reactant will not affect the container anyhow. So that's why a very simple plastic container we will use this. And then two of the most important thing of the whole process is the chemical material, chemical substances that we were using. The first thing is the hydrogen peroxide. This is a hydrogen peroxide bottle. We will use this hydrogen peroxide to make the solution. Also, the vinegar or the acetic acid that we normally use for cooking. It's also kind of cooking. I'm a cook, so I'm a chef. That's why I'm giving you the recipe. So this is a kind of artificial vinegar that we use for regular cooking. This is acetic acid actually. So this acetic acid and this hydrogen peroxide, we will mix up these two material and two liquids and to make a solution. And to make the solution, the amount of vinegar, the acetic acid, this has to be double of the amount of this hydrogen peroxide. So all the way, what we do for making the solution, we take this kind of cup for measuring cup. This is a very small design. When we are doing a lot of designs and we're fabricating a lot of designs, then we need a larger amount of liquids, larger amount of solution. But for this solution, I think this is we need only 1 cup of this acetic acid and half cup of this hydrogen peroxide is okay. So we will do this. So the solution is almost ready. Now we are mixing the ingredients right here. Some people, they use normal salt, I mean the sodium chloride, to make the solution even stronger. But this can fasten the speed of the chemical reaction. But basically this is not recommended for etching process, because sometimes when you use the salt, it also even can damage the main design. The black lines, this can also be removed along with these outside copper areas. So this is a bit risky, not recommended to use the salt to make the solution stronger. Anyways, now we will drop this substrate inside the solution. We'll pour it. So Bismillahirrahmanirrahim. So we will be doing this, keeping our design inside the solution, and that will be kept for hours until you see all the coppers are removed from this surface and the substrate is open, apart from this black designs, these black lines. Alright, the chemical reaction of the etching process has been done. You can see clearly that all the coppers on the top plane, top surface, has been removed and the substrate is open, apart from these black lines of our design. And the solution becomes kind of sky blue. Previously it was like water. It's because all the coppers, they made a reaction with the solution by making something like copper acetate. So right now we want to see how about the ground plane, because it's supposed to be, not affected. Yes, still so far our ground plane is okay. See, all the coppers has been removed from the top plane, but from the black lines, and the ground plane, it's protected because of the duct tape. So we will clean it in the regular water, cold water. We'll keep it here for a few minutes. Then we will remove the ground plane's protector, the duct tape, and we will remove all the black lines to open up our conductive microstrip lines. That is our bandpass filter. And after that we will attach 2 ports at the 2 feed lines on the 2 sides. We have removed the ground plane's protector, the duct tape, and we used a kind of polishing object to clean this ground surface, because due to this duct tape there are some spots over this. So we have cleaned this by using this polishing object. Now we will connect two SMA connectors at the two ports of this microstrip bandpass filter. There we go, this is the fabricated filter after connecting the SMA connectors at the two ports. We have connected these two SMA connectors at the two ports by using regular soldering iron technique. So this is the ground plane and this is the top plane of the filter. We have connected the two ports and our filter is ready to perform. And that's how we can fabricate our microstrip designs using this etching technique. If you're benefited with this video, please share it with others. And thank you for watching this video. Goodbye.